Now next is a small note. If a matrix has all n distinct eigenvalues, then matrix is diagonalizable. A matrix is diagonalizable if and only if A has n Li eigenvectors. A is a 4x4 matrix such that A is diagonalizable. Characteristic is given as x minus 8 square, x minus 9 square. Then we need to find minimal polynomial of x. Try this.
It's option 3.
Reason?
It's a contain least factor.
Eigenvalues are 8 and 9. AM is 2. Now GM will also be same because matrix is given as diagonalizable. Now for lambda equal to 8, I will partition this to how many times? Till number of GM.
2 times.
So 1 plus 1. Highest factor is 1. So x minus 8. And similarly for lambda equal to 9. A matrix A is diagonalizable if and only if minimal polynomial of A consists of distinct monic linear. 1 second. Now if A, A is a n cross n matrix which has eigenvalues lambda 1, lambda 2, so on till lambda n. So what can you say about the eigenvalues of A square? Any idea?
It is lambda 1 square, lambda 2 square, up to lambda n square.
Hmm. For example, let A be a 3 cross 3 matrix with trace as 3 and determinant as 2 if 1 is an eigenvalue of A, then the eigenvalues of the matrix A square minus 2i are option A 1, 2 iota minus 1. Try this.
मेरा तो कोई भी ऑप्शन से मैच ही नहीं हो रहा बिकॉज आई एम गेटिंग 1 माइनस आयोटा 1 प्लस आयोटा.
One of the eigenvalue is 1.
1 plus is 1. Then trace is some lambda 2 plus lambda 3 is 2. Product is also 2. So now equation is x square minus 2x plus 2.
You are taking lambda 2 value in this or lambda 3 value?
I'm generally taking the sum of the roots plus product of the roots ना इक्वेशन बना दी दो चीज रूट्स के साथ सेम ही आएगा.
रूट्स क्या है?
रूट्स आए 1 प्लस आएगा एंड 1 माइनस आएगा.
ठीक है, यही आएंगे. 1 minus iota. So now we need to find eigenvalues of a square minus 2y ना.
इसके में अच्छा मैंने क्वेश्चन पूरा नहीं देखा. ओके ठीक है. It's option two.
A square minus 2y means if lambda 1 is 1, then 1 minus 2 minus 1, and 1 lambda 2 is 1 plus iota, then 1 plus iota square minus 2. So 1 minus 1 plus 2 iota minus 2. And when lambda 3 is 1 minus iota, then 1 minus iota square minus 2. 1 minus 1 minus 2 iota minus 2. So answer will be option D. Let A be a 3 cross 3 matrix with integer entries such that determinant of A is 1. What is the maximum possible entries of A which are even?
नो आइडिया कैसे करेंगे इसको.
Simply we can take any example. मतलब ना इन क्वेश्चंस में ज़्यादा थ्योरी के अंदर जाने की जरूरत नहीं होती. कोई भी रैंडम एग्जांपल ले लो जिसका डिटर्मिनेंट 1 हो, then we can easily do this. For example,
identity matrix.
Identity matrix. Determinant is 1. There are 6 even entries ना, है ना.
Yes.
So answer will be C, because remaining options will be discarded. Na? A, B, D are discarded. Because if I try to change the number of even entries, then determinant will not be 1. If I try to change this last entry or any entry, then determinant will not be 1. But I want the determinant to be 1. So simply I can take example. If A is a 3 cross 3 matrix whose eigenvalues are 0, 1, -1, and determinant of A is 0, obviously it will be 0 because there is one eigenvalue as 0. B matrix is A to the power 100 plus identity. Then find the determinant of B.
It's 4.
Hmm. Eigenvalues for A to the power 100 will be 0, 1 and 1. And eigenvalues for identity will be 1, 1, 1. And there's sum. So eigenvalues of eigenvalues of B will be 1, 2, 2. So determinant is product of all the eigenvalues. So 4. Next question. If A is a matrix whose order is 101 cross 101 such that Aij is 1, means all the entries are 1, then what can you say about the determinant of A minus I?
It's 100.
Hmm. Firstly, A is a 101 cross 101 matrix. All the entries are 1. So A is a, what is its rank? रैंक क्या होगा इसका?
1.
Rank 1 matrix. So eigenvalues will be trace and rest 0, 100 times. So trace is 101. Now I need to find determinant of A minus I, means product of eigenvalues. So eigenvalues of A minus I. 101 minus 1, 100. 0 minus 1 means minus 1 up to 100 times. So determinant of A minus I will be 100 into minus 1 to the power 100. It will be 1 only, so 100. Find its eigenvalue. And also find its determinant. Got the answer?
Doing, ma'am.
Okay.
तो इसकी 11 होगी आइगन वैल्यू, आइगन वैल्यू इज 11 and 1 is 2.
No. Here you can simply write it as a sum of two matrices.
Okay.
One will be a rank 1 matrix 2 2 2, and rest will be 3 3 3. So by doing this you can easily find the eigenvalues. So this is a rank 1 matrix now. So its eigenvalues will be 8 and rest will be 0. So it is a diagonal matrix, so eigenvalues will lie on the diagonal only. So 3 3 3 and their sum. So finally eigenvalues of A are 11 3 3. Now is it clear?
Yes, ma'am.
Determinant will be 33 into 9, 297. Otherwise, if you try to do this by row sum was 11, but by this I cannot find the other eigenvalues. So try to do this by this method because it is a 4 cross 4 matrix na? Which of the following matrices is not diagonalizable over R?
Third one.
In the first one, what were the eigenvalues?
It is 1 and 2.
And AM was 2 and 1.
Game is also 1.
Hmm.
2
So it is diagonalizable. And in the second option, all the eigenvalues are distinct. That is diagonalizable. In third option,
EM is 1.
GM is 1. So it is not diagonalizable. So it will be correct. In option 4 also, all the eigenvalues are distinct. So it is not diagonalizable. So answer will be option 3rd. Let n greater than equal to 1 and alpha beta belongs to real numbers with alpha not equal to beta. Suppose an alpha comma beta is equals to aij is an n cross n matrix such that aii is equals to alpha and aij is equals to beta for I not equal to j. Let dn be the determinant of which of the following statements are true.
was 1.4.
Only second and fourth. So firstly, it is given that on the diagonal alpha is there and the remaining values are beta. So matrix A is after that. What was your approach?
I've taken the value of alpha first alpha 1 and beta 0. By that approach, all were correct. Then I've taken alpha is 2 and beta is 1.
Or you can apply that approach now, which I have told you in this question.
Yes, entries, the eigenvalues I have taken by adding the two matrix.
Alpha minus beta on the diagonal entries, and rest will be
Zero.
So it is a rank 1 matrix. So trace means n beta and remaining will be 0. And here it will be alpha minus beta. So their sum will be
And beta plus alpha minus beta. Beta plus n minus 1 beta.
Dn denotes the determinant product of all the eigenvalues. So alpha plus beta n minus 1 and alpha minus beta to the power n minus 1, because these values were n minus 1 times for all n greater than equal to 2. So by doing this, option 4 is directly correct. Option 4 is correct and option 3 is wrong. Now let me find dn minus 1 also. So alpha plus beta n minus 2, alpha minus beta to the power n minus 2. So we can put these two values in option 1. dn is equals to alpha minus beta dn minus 1 plus beta. We will put dn minus 1 and we will check that we are getting this dn or not. So this will be alpha plus beta n minus 2 alpha minus beta की power n minus 1. Clearly it is not equal to this dn na? है ना? Option 1 is wrong.
Yes.
Now let us check second option. Second option was dn upon alpha minus beta की power n minus 1. So dn upon this, dn was my alpha plus beta n minus 1 alpha minus beta की power n minus 1 divided by this dn minus 1 alpha plus beta n minus 2 I can solve this. Alpha plus beta n minus 2 beta plus beta. So this will be alpha plus beta n minus beta. Again I can take beta common. So left side and right side is same enough. So option 2 is correct. Now is it clear?
Yes, ma'am.
Let A is equals to Aij be an n cross n matrix such that Aij is an integer for all I comma j. Let AB is equals to identity with B equal to Bij, where I is the identity matrix for a square matrix C. Determinant C denotes its determinant. Which of the following statements are true? If determinant of A is 1, then determinant of B is 1. A sufficient condition for each Bij to be an integer is that determinant of A is an integer.
It's C option.
No.
Hmm. Uh, not getting.
Okay.
Hmm.
So in the first option, it is saying that determinant of A is 1 implies determinant of B is 1. And AB is equals to identity was given to me. So as AB is equals to identity, and I can apply determinant on both the sides. Determinant of AB is determinant of A into determinant of B. Determinant of identity is 1, and it is given that determinant of A is 1. So determinant of B is 1. First option is clearly correct.
Yes, ma'am.
And it is given that AB is equals to identity. This means that B is inverse of A. You know? So if I take A as 2002, then determinant of A is 4, which belongs to integers. But what will be B? B matrix will be its inverse, na? Simply, what will be its inverse?
It is 2002. 1 by 4, 2002.
1 by 4, 2002. So
Hmm.
clearly we can see that entries of matrix B does not belong to integers, na?
Hmm.
So option 2 is wrong.
Hmm.
And similarly, option 3 is also wrong by taking this same example, because it is saying that B is always an integer matrix.
Hmm.
Option 4. As AB is equals to identity, this means B is inverse of A. And I have discussed it yesterday that if determinant of A is plus minus 1, then A inverse has integer entries. And here inverse of A is B, na?
Hmm.
This means that B has integer entries. So
Hmm.
option 4 is correct. So answer will be option number 1 and 4th. Let A is equals to 1110, and let alpha n and beta n denote the two eigenvalues of an such that mod of alpha n is greater than or equal to mod of beta n, then alpha n tends to infinity as n tends to infinity. Please mute yourself. Beta n is negative if n is odd.
All are correct.
So firstly, matrix A is 1 1 1 0. So characteristic polynomial will be x square minus trace plus determinant, so minus 1 equal to 0. So eigenvalues will be 1 plus minus under root 5 by 2. So if I take eigenvalue as alpha 1 as 1 plus root 5 by 2, alpha 2 as 1 minus root 5 by 2, so eigenvalues of a to the power n will be beta 1 na? alpha 1 to the power n and beta 1 to the power n. One minus root 5 by 2 to the power n. Okay. So after that, what was your approach?
Applying limits. So first alpha n 10 to infinity as n 10 to infinity, beta 10 tends to 0 as n 10 to infinity.
So option 1 and 2 is correct. And what about third and fourth?
Third, beta n is positive if n is even, because 1 minus root 5 by 2 is negative number. So if n is even, then it will be positive. If n is odd, it will be negative.
Yes, correct. So answer is option 1, 2, 3 and 4. Okay. Now we will discuss some important matrices. First one is nilpotent matrix. Do you remember what was nilpotent matrix?
Yes, it becomes a power k 0. It becomes 0 for some power of the matrix. So where k is the can be index. So nilpotent matrix is basically the zero matrix.
Hmm.
You see?
The matrix A which satisfies A to the power k equal to 0 for some positive integer k is said to be nilpotent matrix, and the least value of k which satisfies is called index of nilpotent matrix, or you can also say that nilpotency index. For example, zero matrix, upper or lower triangular matrix with all diagonal entries zero. So A is a n cross n matrix. A to the power k is 0 for some positive integer k. Now by this we can see that what will be the characteristic polynomial? X to the power k na? And minimal polynomial divides its characteristic polynomial. So minimal polynomial can be x, x square, x cube, x to the power 4, so on till x to the power minus 1, k2, k minus 1, x to the power k. So this means that eigenvalues of nilpotent matrix are 0. Converse is also true. Means if any matrix has eigenvalue 0, then it will be nilpotent matrix. Now let us discuss the diagonalizability of nilpotent matrix. Let A be a nilpotent matrix. Suppose A is diagonalizable. So by definition of diagonalizable matrix, A will be similar to a diagonal matrix na? So here A will be similar to a 0 matrix. Now by definition of similar matrices, there exists P, which is a non-singular matrix such that P inverse AP is equals to 0. It is 0 matrix. So pre and post multiplying by P and P inverse respectively, we will get A equal to 0, which means that 0 matrix is the only nilpotent matrix which is diagonalizable. Is this clear?
Yes, ma'am.
And here I was telling upper triangular matrix with all diagonal entry 0. For example, 0 1 0 0, 0 0 1 0. So if I want to check what will be their nilpotency index, so I will multiply this again. So nilpotency index will be 2 na?
Yes, ma'am.
So by this example and another example, so this is also nilpotent matrix, but it is non-diagonalizable. So only zero matrix is the nilpotent matrix which is diagonalizable. Rest can be nilpotent matrix, but they will be non-diagonalizable. For example, here also it is non-diagonalizable. What will be the eigenvalues of this matrix?
It is 0, 0, 0.
What about GM? 2 minus rank of A, 1 na? So AM is not equal to GM, so not diagonalizable. So an important note, rank 1 matrix with trace equal to 0 is nilpotent. Next question. Let T be a n cross n matrix with the property T to the power n is equal to 0. Which of the following is true? T has n distinct eigenvalues. Second option, T has one eigenvalue of multiplicity n. Third, 0 is an eigenvalue of T. T is similar to a diagonal matrix.
Option 3, 0 is an eigenvalue of T.
So firstly, this is a nilpotent matrix, so it has eigenvalues 0. 0, 0, 0, 0 means n times. So it does not have n distinct eigenvalues, so first option is wrong. So T has one eigenvalue of multiplicity n. What will be the characteristic polynomial? X to the power n, na? So it has one eigenvalue of multiplicity n. Second option is correct. Third is also correct. Fourth is wrong
Hmm.
because T is similar to a zero matrix. So answers are option 2 and 3. Let V be the vector space of all real polynomials of degree less than equal to 10. Let Tpx is equals to P dash x for P belongs to vector space V be a linear transformation from V to V. Consider the basis let A be the matrix of T with respect to this basis. Then first option trace of A is 1. Second option determinant of A is 0. Third option there is no m belongs to natural number such that a to the power m is 0. Fourth, A has a non-zero eigenvalue.
It is determinant phase period.
Hmm. So firstly tell me what will be that A matrix?
It is first column is 0.
Hmm.
That 11 will be there. So second is 1, 0, 0, 1. Diagonal entries are also then 2, 3, 4,
And then
up to 10. Yes.
and rest are 0.
Yes.
So this is upper triangular matrix.
With the zero entries on diagonal.
Hmm. Nilpotent matrix. So all eigenvalues are 0. So option 4 will be discarded. Option 3 is also wrong. And determinant means product of all the eigenvalues will be 0. So trace cannot be 1. So answer is option 2. Let V be the vector space of polynomials of degree at most 3 in a variable x with coefficient in R. Let t is equals to d by dx be the linear transformation of V to itself given by differentiation. Which of the following are correct? T is invertible. 0 is an eigenvalue of t. There is a basis with respect to which the matrix T is nilpotent. The matrix of T with respect to the basis is diagonal.
इसमें ऑप्शन 2 एंड 3
Reason?
because again it is nilpotent vector, so 0 is an eigenvalue of t. So with respect to the same basis 1x x square x cubed, it is nilpotent, and with respect to basis 1 plus x 1 plus x square also it is nilpotent.
So as it is a nilpotent matrix, so eigenvalues are 0. So T cannot be invertible. Second is also correct, and third is also correct. And what about fourth? It is saying that matrix representation of T with respect to this basis is diagonal. But when we will see that it is 0, 0, 0, 0, 1, 2, 3, and rest entries are 0. So it is not a diagonal matrix, na?
Yes, it is not diagonal.
That's why option 4 is wrong. So answers are option 2 and 3. Next is idempotent matrix. It is a square equal to a. So characteristic polynomial will be x square equal to x, means x square minus x equal to 0. So eigenvalues will be 0 and 1. Now minimal polynomial divides characteristic polynomial. So this divides so minimal polynomial can be
it is x and x minus 1 both नहीं आएगा x into x minus 1
because it must contain at least one factor of eigenvalue. So let us see some examples of idempotent matrix. Zero matrix, identity matrix, 1 0 0 0, this matrix 0 0 0 1. So if I want to find some, I mean how I am writing these, if a 0 0 b, its square will be a square 0 0 b square, and it should be equal to, if a is this, then a square is equals to a, means this should be equal to a 0 0 b. This means that either a can take 0 or 1 value, and similarly B can take 0 or 1 value. So by this only I have written these 4 examples. One by two, 1 by 2, 1 by 2, 1 by 2. Tell me whether it is idempotent or not.
Yes, it is important. Important बोल रहे हो?
Idempotent.
Idempotent. Yes, it is idempotent.
Hmm. Similarly, what about this?
It is also idempotent. Diagonal entries are 1, 0, 0. The eigenvalues are 1, 0, 0.
Rank 1 matrix. Na? So if A is idempotent, then all eigenvalues of A are equal to 0 or 1 or both. But converse is not true. So if I take an example in which eigenvalues are 0 or 1, but then also it is not idempotent. So eigenvalues of A are on the diagonal because A is upper triangle matrix. So eigenvalues of A are 0, 1, 1. Now I need to check whether it is idempotent or not. Clearly it is not equal to A, na? Means A is not idempotent. Next, involutory matrix. The matrix which satisfies A square equal to I. I is identity matrix. Is said to be involutory matrix. Example, identity matrix minus I or 1 0 0 minus 1 is also there, minus 1 0 0 1. 0 1 1 0. So if I multiply it with itself, then I am getting identity matrix now. So it is also involutory. 0 1 by 2 2 0. Again I am getting involutory matrix identity. So from this I can say that it can be like this: 0 1 by a 0. Where a is non-zero. So in general, this can be an involutory matrix. This was for 2 cross 2, and for 3 cross 3, this will be involutory. For 4 cross 4, 5 cross 5, alpha, beta, 1 or minus 1, 1 by beta, 1 by alpha. And rest entries are 0. Now some results for idempotent matrix. Idempotent matrix was A square equal to A. First is I minus A square is equals to I minus A. I minus A square means I minus A into I minus A. So I into I minus I into A minus A into I minus A square. So this will be I minus 2A minus A square, and A square is equals to A. So I minus 2A minus A. So this is I minus A. Second, rank of A is equals to trace of A. So if I see like this, that A is similar to this type of matrix whose m times entries are 0 on diagonal, and these are n minus m times entries are 1. So what will be the rank of A? Number of non-zero rows. There are n minus m non-zero rows, and trace is also n minus m. This implies rank of A is equals to trace of A. Third is rank of I minus A is equals to trace of I minus A. And last one, rank of A plus rank of I minus A is equals to n. So after that we will continue from 3:30. Okay.
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 Thank you.
You're welcome.